So let's go ahead and get started with our lesson today. 6.1 Angles of Polygons. Our I can statement for today is I can find and use the sum of the measures of the interior angles of a polygon as well as I can find and use the sum of the measures of the exterior angles of a polygon. So moving forward, here's some vocab words we're going to review. First one here, diagonal. Diagonal is basically anytime we have a shape and we take one corner here through the polygon to the other corner. So for example, if we had this parallelogram here and this was ABCD, well, segment AC would be a diagonal as well as segment BD, okay? And we're going to see this in a lot of different shapes, especially this chapter talking about quadrilaterals. So anytime we got basically a segment that goes from one corner to the other corner, that is going to be a diagonal. Talking about polygons here, so we're going to learn a lot of different polygons, and I want to take a look at this right here, convex versus concave. So whenever we have a convex and a concave polygon, we can kind of think of it like this. So we have right now, this is a convex polygon. That's basically going to be anytime our angles are less than 180 degrees. So all 5 angles here of this polygon are less than 180, so this is convex. As you see, when I bring this down and I make this angle over 180 degrees, that's going to be a concave polygon. So I like to kind of remember it. Whenever our angle is more than 180, it looks kind of like the polygon is caving in on itself. So that's how I remember that this is concave anytime it's greater than 180. As you see, as I bring it back below 180, it goes back to a convex polygon. Regular polygon. Regular polygon is when we have all angles, all sides congruent. All angles and all sides congruent. Okay, so a perfect square here where we have all of the sides being the same, all of the angles being 90 degrees. That would be an example here of a regular polygon. A regular triangle would be an equilateral triangle, right, where all of the angles are 60, all of the sides are the same. So that's what a regular polygon is there. Now, let's go ahead and look at our first theorem that we're going to talk about in chapter 6. This theorem right here is all about the interior angles of any polygon. So not just a triangle, but any amount of sides here. So it says that the sum of the interior angle measures of an n-sided polygon, notice it says n-side convex polygon, is n minus 2 times 180. N minus 2 times 180. So when we say an n-sided polygon and we have n in our formula, the n is going to be the number of sides. So in our formula here, n minus 2 times 180, n is simply just the number of sides. All right, so if we wanted to test this theorem here, if we thought of a triangle, since we all know that a triangle is 180 degrees, if we wanted to know to make sure that this formula works here, we put in the amount of sides in a triangle, which is 3. We subtract 2 and we multiply that by 180. So if we did this formula here for a triangle, you're going to see 3 minus 2 times 180 is 180 degrees. So we know for sure here that the measures of all the angles of a triangle is 180. So this formula here does work. So we're going to be able to use this no matter how many sides we have. Could be 10, could be 20, does not matter. We'll be able to use this formula here to help us figure that out. So one of the big things to remember today, if you don't remember anything from this lesson, make sure you remember this formula. N minus 2 times 180, and that is for the interior. The interior, so the inside angles. So starting off here, find the sum of the measures of the interior angles of a convex nonagon. Okay, so this is exactly what we learned on that last page, except for we probably don't know what a nonagon is. All right, so a nonagon has 9 sides. So what we need to do is take our formula that we just learned on that last page, n minus 2 times 180, and we need to do this for a nonagon. Okay, so we know that a nonagon now has 9 sides. So this is going to be 9 minus 2 times 180. 9 minus 2 times 180. Well, 9 minus 2 is 7, and 7 times 180 is 1,260. So we're going to say here that a nonagon has 1,260 degrees, which would be the sum of the measures. Okay, so that is the total amount of degrees that are in this polygon. So anytime that we're asking for the sum of the measures, we will use this right here, n minus 2 times 180. Next question. Next question says a mall is designed so that 5 walkways meet at a food court that is in the shape of a regular pentagon. Find the measures of one of the interior angles of the pentagon. Well, I think a lot of us know here that a pentagon has 5 sides. But the difference between this question and the previous question is this one doesn't ask for the sum of all the interior angles. It asks for one of the interior angles. So what we're going to do is we are going to use our n minus 2 times 180 formula. But after we get this, this is going to give us the sum of the measures. Okay, so let's go ahead and do that. So pentagon is 5 sides, so this is going to be, n is going to be 5, so 5 minus 2 times 180. Well, 5 minus 2 is 3. And 3 times 180 is 540. So right now we have that all of the angles here added up in a pentagon are 540 degrees. Well, if we know here that this is a regular pentagon, we know here that all of these angles in this pentagon are the same, because this is a regular pentagon. That's what that regular means. So if we know here that all 5 angles are the same and they all add up to 540, well, then what do we need to do between 540 and the number of angles that we have? Hopefully you said we need to take the whole thing and divide it by the number of angles. So we're going to take the sum and divide that by the number of angles. So if we said there's 5 sides here, that means there is 5 angles. So if we're looking for one of those angles, we're going to take 540 and we're going to divide that by 5. Okay, so for one of these angles here, one of the interior angles, we're going to get 108 degrees. 108 degrees. So all 5 of these here would be 108. Okay. Okay, let's think about this question here. It says the measure of an interior angle of a regular polygon is 150. Find the number of sides in that polygon. So we want to find the number of sides given the degree of each interior angle. So we know that the formula that we're using for interior angles looks like this, right? N minus 2 times 180. I'm actually going to write it over here. N minus 2 times 180. And that always gives us the sum of all of those interior angles, right? So we know, based on some previous questions here, if we multiply n minus 2 times 180 to get us the sum, and we wanted to figure out how many degrees were in each angle, that we would divide n minus 2 times 180 divided by the number of sides, right? If we divided this by the number of sides, what that would give us is the degree in each angle, okay? So this formula, n minus 2 times 180 divided by n, actually gives us the degree of each interior angle. So I'm going to say each angle. Well, we know what each angle is, right? We know, based on what we've been given, that each angle is 150. So we know here, we're going to rewrite this formula. We're going to say n minus 2 times 180 divided by n is equal to 150. N minus 2 times 180 divided by n is equal to 150. So this right here, this formula, n minus 2 times 180 divided by n, remember, gives us the degree of each angle in the polygon. 150 is the number of degrees that we have in the particular polygon that we're talking about right here. So if we wanted to solve this equation here, what we would need to do is we could either do one of two things. We could either just multiply this n across, or we could kind of say essentially the same thing. We could cross multiply. Okay, so we could kind of view that this is a 150 over 1, and we could cross multiply. All right, so when we cross multiply here, this is going to be 150n is equal to n minus 2 times 180. All right, now from here, if we want to solve this for n, what we're going to do is we are actually going to distribute this 180 through to both terms. So we're going to say here 150n is equal to 180n minus 360. And from here, if you notice, if we subtract our smaller n, 150n, we will have to add a 360 over to both sides. So we're going to do here where we actually just subtract our bigger n, 180n minus 180n, and we're actually going to get a negative number over here. So we're going to negative 30n is equal to negative 360. So the reason I'm okay with having a negative number over here is because I know that this 360 right here is also negative. And I know that when I divide a negative divided by a negative, that's going to give me a positive. So because we know that, that's the reason I left this the way I did. The reason I subtracted the bigger n instead of subtracting the smaller n. So now we're going to divide both sides here by a negative 30. When we do that, we get a positive 12. So our answer here, the number of sides that we were looking for, is going to be n equals 12. So quick recap here. The formula to get each angle was n minus 2 times 180 divided by n. We knew that the angle that we were looking at here was 150 degrees. So we set up that formula n minus 2 times 180 over n is equal to 150. All right, let's take a look at this example here. So it says, find the measure of each interior angle of this pentagon, HJKLM. So as you can see, looking at this pentagon, we do have 5 angles. And much like in the previous example, we could figure out here what all of these angles add up to by using our formula, n minus 2 times 180. So if we did that like we did in the last question, we could figure out here how many degrees are in this total. And just like in the last question, we find out that it is 540 degrees total. So now that we know that all 5 of these angles add up to 540, we want to do just that. Okay, we want to take up all of these angles, we want to add them together, we want to set that equal to 540. So I'm going to write it out. It's going to be really, really long, but we're going to condense it, and hopefully it'll make more sense once we do that. So add up all 5 of our angles here, 3x plus 14 plus 3x plus 14 plus 2x plus our other 2x. And you cannot forget our 5th angle here, 142. So that is equal to 540. From here, go ahead, combine your like terms. So when I see all my x's here, I'm going to underline them in red. So 3x, 3x, 2x, and 2x. I'll take my green here and I'll underline our non-x's, so 14, 14, and 142. So when we do this, 3x, 3x, 2x, 2x, that's going to be 10x. And then 14, 14, and 142, that's going to be 170. So 10x plus 170 is equal to 540. So again, all we did here was we added up all of these angles. We set them equal to the total amount of degrees that we know is in this pentagon. So 10x plus 170 equals 540. Go ahead, subtract that 170 from both sides. When we do that, 540 minus 170 gives us 370. So 10x equals 370. Divide both sides here by 10. And we're going to get x equals 37. Okay, so we get x equals 37. That is not our answer, unfortunately. We do have to go in and input our x here into each of our interior angles. So luckily, we only have to do this 2 times, since it looks like our base angles M and L are the same, as well as H and K are the same. So 3 times 37 gives us 111, plus 14 is going to give us 125. So angle M, angle L, since those both have the same algebras, those are both going to be 125. Now angle H, angle K, those are also going to be the same. Just multiply 2 times 37. And when we do that, we're going to get 74. So each of these angles here are 74 degrees. All right. Let's move on now, not to interior angles, but we're actually going to talk about exterior angles. So this theorem here, 6.2, is all about the sum of the exterior angles. Okay, it tells us right here that the sum of the exterior angles of a convex polygon, one angle at each vertex, is 360 degrees. Okay, 360 degrees. So when we take the exterior angles of any polygon, no matter how many sides, as long as it's a convex polygon, that sum is going to be 360 degrees. So for example, if we have 6 angles like we do here, all 6 of those angles are going to add up to 360. Let's say, for example, we have something a little bit more familiar. We have a triangle that has 3 exterior angles. Okay, those exterior angles are going to add up to 360 degrees. Okay, 360 degrees. So we could say here angle 1, angle 2, and angle 3, add those together, that's equal to 360. We'll watch this YouTube video in class. We do not have time to do it on this video. Right here, question says, find the measure of each exterior angle of a regular decagon. A regular decagon. So we got to ask ourselves here, how many angles does a decagon have? There are 10 sides or 10 angles in a decagon. So that is 10. We know that all 10 of those sides are going to add up to 360. So we're going to take the sum of our exterior angles, so we're going to divide that by the number of sides or the number of angles. They will be the same. So you take the sum of all of your exterior angles here and you divide that by the number of sides. So this is going to be 360 divided by 10 sides. That's going to give us 36 degrees for each exterior angle. Looking at the next one here. Looking at the next one's a little bit more complex, but it's not too much different. Not too much different. So we have 1, 2, 3, 4, 5, 6, 7 exterior angles, and we need to find x. So we have 7 exterior angles. We need to find x. Well, we know that all of these exterior angles here are going to add up to 360. So what we're going to do is we're going to take each of these angles, add them together. So what we're going to do here is we're going to take each of these angles, we're going to add them together, and we're going to say that that is equal to 360. So much like we did with the interior angles, this is going to look very similar. I'll go ahead and write all of this out, but if you would like to combine your x's and your non-x's before the first step, that is also that can also be done. So I'm going to go ahead and start in order here. This is going to look a little wild because there are so many angles we have to write in. Didn't quite make it here. Didn't quite make it. So that looks really crazy, right? That looks really crazy. Just looking at this long equation, this just doesn't look like this could ever be found. So this is what I want you guys to do anytime we know this situation. So we know that we're going to have to add up all of these and set this equal to 360. So something that may be easier than writing everything out is just going through and combining your x's and your non-x's before you start your equation. So I'm going to go through here and underline each of our x's in red and add them together. So this is 5x, plus 5x is 10x, plus 4x is 14x, plus 5x is 19x, plus 4x is 23x, plus 2 is 25x, and plus 6 here is 31x. So out of all of our x's here, we add those together. That is 31x. Now let's do our non-x's. So this is a positive 5 plus a positive 3, which is 8, minus 12, which is negative 4, plus 3 is negative 1, minus 5 is negative 6, and minus 6 is negative 12. So 31x minus 12 equals 360. 31x minus 12 equals 360. So go ahead, add that 12 to both sides. And then we are going to divide by 31. So 31x equals 372. And divide both sides by 31. We're going to get x equals 12. X equals 12. Okay, so recap there. We know that all these exterior angles add up to 360. So all we do is we just take all of our exterior angles, we add them up, say that they are equal to 360, and solve for x that